Hello, everyone. Welcome to Manufacturing Day 2020. Welcome to our second day. Thank you for joining us again. If you haven't done so already, please remember to put your name into the chat box so we know you are here. Remember, you can win an awesome iPad at the end of your third call. So it's really important for you to put in that name. Awesome. I see a lot of names come in. Thank you very much. So just as yesterday, a little bit of housekeeping. This session is being recorded and everybody is muted right now. If you do have a question, unmute yourself, ask that question, or of course you can always use that chat box. And I am super happy to have two of our departments here today with me, and this is the welding department and also the mechatronics department. And this is what we'll do in the next 30 minutes. First, we're going to get started with welding. I will show you a short video so you can see the lab, you can see what we do in the lab. Then I will ask our students to talk a little more about the program, what they do in class, why they started going into this program, etc. And then you will have a little bit of time for questions. All right, so let me get started with our very first video. And this is the wrong video. This is the video.
Here in welding, we have someone demonstrating how to use the oxy-fuel torch to cut. We also have multiple fabrication projects that go on at. Here in welding, we have someone demonstrating how to use the oxy-fuel torch to cut. We also have multiple fabrication projects that go on at one time. Here we have somebody welding up their project using the MIG process. We have another person here that's cutting up their project using the plasma torch. We have stick welding, as well as TIG welding. And here's someone demonstrating to another person how to use the cup walk method while using the TIG welding process. Here we have somebody tacking up their project using the TIG method. And now we have somebody that is grinding on their plate using the special grinding room that we have.
Hey guys, Miranda Kassarba here, and I'm with Isaiah Johnson, one of my students who's in my cutting courses, and I'm going to demonstrate to him how he's going to plasma cut. What we're going to do, we're going to cut our machine on. Everything's plugged in. We're going to take our air hose, make sure we're hooked up to the compressed air. See our PSI is coming up. Set it a little lower. 85 amps. Alright. Now come on in. All I'm going to be able to do is pull the trigger, hear that air that's coming out. You're just going to be able to cut right here on a straight line. Have your hands out here. Make sure your legs are away from where the splatter is going to be, okay? Put your helmet down. Yep, that's all we have, guys. Be sure to take welding classes at Alamance Community College. Thanks again.
All right, still going. Didn't want that. All right, guys, so First of all, thank you so much for this video. Now, tell us a little bit about you. Tell us why you started going into the welding program and what you do in welding. And yeah, tell us a little bit about that.
You want to start or you want me to?
I guess I'll start since
Okay.
the reason why I got into it is because there were so many different. I knew I wanted to do a trade, and I've always been great with my hands. I suck at anything electronic, and every field that I was thinking about didn't really have what I wanted in it, and I wanted to do diesel mechanics, regular auto mechanics. I wanted to go to UTI. I wanted there's so many different fields that I wanted to go in, but welding was one of those that when I actually tried it with my father, that was one thing I actually enjoyed and didn't get frustrated with. And um, it didn't feel kind of dead end like some other things kind of felt like. And it was just the perfect suit for me. And yeah.
I gotta say, my love started for it with family. My grandpa's brother was a welder all of his life, and I always heard about how he could build anything, make anything. He did a lot of work on my dad's drag cars while my dad was growing up. So that really interested me. And then I came into school to learn it because I wanted a career that's universal. You know, tomorrow I can be welding on a car. The day after that, I can be doing tubing for, you know, a hospital or something that's pharmaceutical.
Another thing about it with welding, there's so many different fields you can go to instead of just having to focus on one thing and having that freedom to do really whatever you want to and always have a job and a way of income is amazing to think about. So yeah.
So tell me a little more about what you do in the classroom or in the lab.
Well, it can vary depending on your classes. Some classes are very, very like specific, like the beginner level classes. They really pride themselves on teaching you first the safety, and then they teach you how to properly weld or cut or whatever your class is for. We have some classes that are for machining, and some are actually for old school blacksmithing. But a lot of the classes can vary because you have projects. So again, like I said, one day you might be working on something for a car, and the next day you might be building a box to hold water or something like that. It's really up to the instructors and up to you as a student what you do.
And yeah, me being a beginner, they try to get you not only the basics of welding, but also the discipline part too of what you're doing and the safety part about it. Like every time I don't come in with safety glasses, I can guarantee you one of the instructors is going to come at me real quick. And cleaning, making sure doing everything safety wise and not having brooms close to the floor so you don't start a fire and stuff like that. Yeah.
Right. So I don't know anything about welding. So are there different types of welding or is everything just the same? So tell me a little more about that, please.
There are many different types of welding. Like you saw in the video, the guy that was cutting, you can actually weld with that simply just using a hot flame. You can go as from simple as that, which is how they did it in, you know, the early 1800s into the 1900s. You can do that all the way to the modern ways. You have multiple different types. You have TIG welding, you have MIG welding, you have stick welding, and then you have oxy-fuel welding, and multiple other forms of cutting as well. A lot of it uses electricity to heat up the metal, and then there's various ways of adding the extra metal that actually creates a sound weld, which they teach you a lot about in the school.
And do you use that for different metals or how does it work?
Yeah, so a lot of it is practice as well as kind of the situation, you know, like production. You might would use one form of welding versus something very meticulous or a tight corner. You would use another type.
Okay.
It's one thing, especially starting out, you'll start one class and you may have that class multiple days a week and you get used to that one form of welding. But then in the mix of that, you have a different form of welding that you also need to learn. So when you're starting out and then having to learn how to do that different type of welding, it's almost like having to train yourself to not just get used to one thing. You can't really settle on just one thing. And it's all about learning. I feel like for me so far, it's all about being able to learn new stuff every single time. And I feel like that's the fun part about it. Learning the new stuff and being able to mess up and try again nonstop. Yeah.
That's great. And I can see we already have the first question. Awesome, guys. Just keep them coming. So the first question for you is, what is the hardest thing that you have welded?
Oh,
Tell me about that coolant thing we can make with the reservoir.
Well, as I mentioned earlier, cars run in my family. So I've recently taken on a private project in the school, which they will let you do in the higher up classes. It's basically an overflow tank. It allows coolant to come from the radiator and just collect excessively, and it's not pressurized, but it's made out of aluminum. And in the school, we have been fabricating every single part for it. And it all has to get welded up, measured correctly, checked, double checked, all of that. So I'd say that's the hardest thing I've been doing.
Hardest thing I've been doing is doing blind corners, where basically instead of welding in a straight line, you have to weld in that straight line, get into a corner, and you got to keep that bead going and then kind of go in a different direction. Yeah. In different, like, oh man, it sucks.
Yeah, I didn't like them either.
Yeah.
It's
Sounds
probably
difficult.
the hardest part for me.
All right. Any other questions? So let me ask you, what do you want to do when you grow up? So what is your perspective after going to ACC?
Well, ACC does a really good job of helping you get employed after school. They definitely don't just leave you alone once you finish. They really hook you up there. So my future plans is to work somewhere, get some real world experience outside of the classroom, really get a grasp on what I'm doing and my skill, and then open up my own shop and mess with cars.
That's awesome.
His basically, I didn't know I had the same thing.
Same thing?
Yeah.
All right, next question. Did you have to learn how to read blueprints?
Yeah, so there is actually a class. It's called Blueprint Reading. It gets very extensive. It doesn't just teach you how to read them. It teaches you how to draw them. Because in this trade, not some places you just read the blueprint and build it, but some places someone will come up to you and say, hey, I need you to build this, and you got to start from scratch and completely draw it all out.
I haven't had to read a blueprint yet.
Okay, any other questions? Did either of you take the blacksmithing course?
Yeah, I did. The blacksmithing course is a very unique one. You learn very fast that you suck at hammering, no matter how long you've done it. You learn how to properly use a hammer, which I never thought that I would have to be taught either. But you get to make a lot of cool stuff. Again, it's kind of varied. When you first start out in the blacksmithing course, they give you a lot of like ideas or things that you have to make for a grade. But after that, they encourage you to be creative and make something of your own decision or choice. So one thing that I really liked is I made a herb chopper. It's not a knife. It's specifically made for like just dicing herbs and stuff. But I put all kinds of curves and twists in it and stuff like that. And they grade you for it, but they encourage you to try to be creative.
You'll get to take it, Isaiah. You'll have to.
It's really fun.
Yeah.
It's hard and it's hot. It's so hot, but it's fun.
Miranda, I have a question for you, since you are one of the few women in this industry. So what is the fun thing for women in welding?
I always like to say that we always just have our independence, is like what these guys pretty much say is that there's that option to be able to go anywhere in the field and have the opportunity to work with this type of product and still make an income. And then if I have to, I can change it up and work somewhere else, make this type of product and still be able to have an income. So I always like it because of the whole just being on my own, having my independence, and just saying that, yeah, I can go and I can do that.
Awesome. All right. Well, thank you so much, Welding Department. That was very interesting. Thank you for sharing your story with us. And I am going to go over to Mechatronics. And once again, I will start sharing my screen and you will be able to see another video.
Hello, my name is Garrett Petit. I am a student enrolled in the Mechatronics engineering program here at Alamance Community College. Some people have asked me what exactly is Mechatronics, and I like to describe it to others as the melting pot of engineering. It combines electrical, mechanical, and automation into one varied course. I pursued Mechatronics because I was interested in the many different topics that were covered by the program and the amazing job opportunities that were available. Plus, I get to play with giant robot arms, and that's always a plus. Today, I'm going to show you some of the stations that I've learned to operate and what is associated with them. This is the Fluid Power Training Station. Here, students will learn about hydraulic and pneumatic power, its properties, and applications in industry. Students will use these devices placed on this pegboard, connected to cylinders or motors, and operate them. As you can see, this is very heavy and difficult to lift. But now let's see how easy it is to lift using hydraulic power. A lot easier, wouldn't you say? Now, much like a lot of the classes here in the Mechatronics program, this is a very hands-on learning experience where students will get valuable real-world application knowledge. And on the flip side, we have our pneumatic station. Unlike hydraulics, which uses oil, pneumatics uses air. Air is preferred in robotics as it is cleaner and more efficient to use. This is my personal favorite room in our building. This is the PLC room. PLC stands for Programmable Logic Controllers. PLCs are used to control large automation processes and complicated tasks. Here, students will learn how to program and control PLCs and the functions that are associated with them. Today, I have set up a simple program that controls the lights and motors on this station. This orange light will tell us if the motor is off. When we press this button, the motor will start, and this light will tell us the motor is running. And we can stop the motor with this button. We can also step a counter to keep track of these lights here. So when we press this button, one light will turn on, another one, and another one. And we can reset this process with this button. And isn't it amazing how you control so many inputs and outputs with just a simple program? And that's what I love about this class, is that it promotes experimentation and your own way of learning so that you can do it your own way. There's a million different ways that you could do that exact same program I did, but it's all up to just how you want to learn it. And now we come to the most fun station in the entire classroom. This takes everything we learned from fluid power, electrical, and mechanical, and combines it all into one big project. This is the Phonic Robot Arm. This was donated to us by a local company that no longer had any use for it. Now, when it first arrived at the college, it was a little dysfunctional, but by applying what we learned in our classes, we were able to fully fix it, and now it is operational. By using this teach pendant, we can tell the robot to move in any direction that we want. We can also put a program into the robot that allows it to perform a task automatically. And we can program it to do all kinds of things, such as drawing a circle with a pen, picking up a metal block, shake hands with people, throw basketballs at people, and also plot robotic uprisings. It's a lot of fun. And that is just a sample of what we get to do here in the Mechatronics program. I'm very glad I decided to pursue this, as this is one of the most fun and rewarding programs that the college offers. Whether you want to pursue a solid, sustaining job, learn more about electricity, or or just mess around with the stations. There's something here for just about everybody. Thank you for your time.
Okay, let me stop this. Yep.
Hi.
All right, and we do have Garrett with us today. Garrett, are you here?
Yes, ma'am. I'm glad to be here.
There he is. Perfect. So tell us a little more about why you decided to go into mechatronics.
Well, at first, I was really only interested in the electrical part of it because when I was younger, I used to tinker around with my video game consoles all day because when they would break, because I would just break them all the time, just try to fix them. But as I got older, I really wanted to apply it to something more broad instead of just, electronics. So when I was looking at the available courses, I saw mechatronics, and when I started reading into it, I saw that there were just so many topics covered by it. There was, like I said, electrical, mechanical, automation, but even more than that. And that's what really drove me to pursue it, because there was the really good job opportunities and also just my own curiosity of, what was there.
So same question for you. Tell us a little more about what you do in the classroom, what you learn, the classes you take, etc.
So during the first semester, you really learn the fundamentals of like electricity and a little bit of physics thrown in, just so you could better understand. And then your second semester, when it really gets onto the hands-on course, I mean, like with those stations on there, you learn everything about them. You get into the detailed applications of it, what those devices do, and you mostly just learn about how they work. Like when you look at a giant assembly line, you just think, oh, it makes hot dogs or something. But then when you look at each individual part, there is so much going on there that it's incredible. And like you saw with the giant robot arm, that's a perfect example of it. I mean, that combines everything that you learn at the college, at this course, into that one class. And while it is very hard, it is so rewarding because there's so many tiny little details that you can fix and tune to just make it better.
So a question that I get asked a lot about mechatronics is, do you need to be good at math?
Oh, yes, I wondered that myself. And you do need to be good at math. However, what I learned is, while you do need to be good, you don't need to be really good. Because in most of the classes that are involved with math, they teach you just the basics of it and then develop on that. So you could have pretty much any mathematical background and you could still be in the course, in the class. Like, for example, with the introduction to AC/DC. While it is a very math-intensive course, you're taught the basics at any level. So you could come in just straight off of algebra and you could still be in the course.
Okay. So same question for you. What about your outlook, your professional outlook? What do you want to do with this degree after college?
After college, I really want to pursue like maintenance. I really want to get into large machines and just figure out what's wrong with them, because it's really satisfying just to have this giant machine where one thing breaks down, but then you fix that and it all gets back up and running. And the one good thing about the mechatronics is that's only just one of many different possible fields you could go into. I mean, this could even just be a stepping point to even more advanced engineering courses. Like after mechatronics, you could pursue electrical further, or really anything that's involved with it.
Awesome. Do we have, what is your daily schedule? Here's the first question.
So before everything was online, the daily schedule was usually Monday through Thursday, and classes would range from night to morning, but generally it was 2 classes a day, but they were usually very short classes. The only long ones were usually the ones at night, but those weren't very hands-on. Those were just kind of information, like electrical. Now with the online, most of the classes are all online. However, because this is such a hands-on course, it's kind of required to do some hands-on work. Right. So 2 of my big classes this semester are almost exclusively hands-on real experience with some online assignments thrown in just to say, you know, it's online, but it really is mostly hands-on.
Okay, just keep your questions coming. But I just had a question for you too, Garrett, and I forgot. I'm so sorry.
It's all good.
What's about the hands-on part? Blank. See? I just went blank. Thank you, Louis. Thank you. Well, calculus and physics out a lot.
I'm assuming that means like, is calculus and physics like the big portion of it? And physics, yes. In fact, one of the things I took was a introduction to physics, but that was only introduction. You didn't need to go into high depth levels. And calculus, you don't need calculus, even though it is, you know, it is recommended because it is, you know, it's a higher level of math. You don't actually need calculus. You could be just algebra.
So Garrett, what's the hardest thing you have programmed?
Oh boy. This was in my first PLC class in my first semester. And my instructor, Todd Sondels, he devised this program where it was, okay, make me a haunted house light show where you have the lights at the top that like go on and off in a certain way. And I thought, well, that's easy. That's just a bunch of lights going on. Then I got into it. And that project took me about 4 weeks. And I got done early compared to the rest of the class. And it was very difficult because since it's an introduction, you don't know the more advanced functions yet. So you're struggling to figure out how to make it work. But in doing so, you learn more about it. But yes, I would say that is most likely the hardest thing I programmed. It took me a lot of extra hours to get that done.
You should go by his house now and see if he's using your programming for that.
I think he's actually still using it even in this semester, which
awesome.
I feel so bad for those poor students.
All right, I did remember my question. So if one of our students on the call today is interested in going into mechatronics, what is your advice for this student?
My advice really is just stay on top of like what you're learning, because one of the things I noticed is while grades are important, obviously, for classes, the biggest thing is that you just understand the fundamentals, because later on in the semesters, it builds on that. Like that first PLC class, my second semester I took one, my third semester I had to do something similar, and then this semester I'm doing a class that also uses it, but more advanced. So my suggestion would be just make sure you understand the fundamentals and the basics above all else, because that is what you build everything on.
Okay, I do have another question for you. What programming language would you use? Would Python help?
So I wish I forgot to elaborate on this a little bit in that video. When I say program PLC, it's not actually traditional programming where it's like Python or Ruby or some kind of programming language. What it is we take what's called ladder logic programming, where it's a bit more of a visual representation of what's happening. So there's like, and the reason they call it ladder is there's rungs on the ladder, and you tell it to do something on this rung, and then the rung on the bottom, you keep doing that over and over again. And that's another good thing, is that you don't need to learn how to actually code in order to program PLCs. There are other options to code PLCs. There is, I believe, a way to do a more traditional coding method, but that is for more advanced users who want to kind of challenge themselves.
So what would be a typical job that you can use mechatronics in?
The number one job I'd say typical would just be like general maintenance of large machines. So like example, that factory assembly, something goes wrong, your boss comes up and says, oh, okay, this broken, fix it. And you ask, okay, well, what's wrong with it? I don't know, it's broken. Okay, well, now I need to go in with my knowledge and, figure out what's wrong and fix it from there. Other things, manufacturing is another big one where, because you have electrical and mechanical knowledge under your belt, you can really be hands-on in like the manufacturing business, because you can tell the dimensions of something. Okay, it needs to be this, it needs to be programmed this way, it needs to be placed this way. So in general, maintenance is where you would probably first start out, but it builds on that with experience.
Okay, I have one last question for you, Garrett. Will jobs be harder to get because of the fact that I went to a community college, or will that not matter?
Believe it or not, you get community colleges, people who come out of this course have a better chance of getting jobs than if you went to, say, a four-year college. And the reason is because at especially ACC, you're being trained to get a job, while higher like learning courses at four-year colleges are more technical, like professional understandings of it. At ACC, you are learning to get a job. So you actually have an edge over some other students who went to a larger college, like a four-year. And that's why I took community college too, because the job was the big thing. Like after you get out, you're not, well, obviously you're not 100% guaranteed to get a job, but your chances are much higher than all the other.
Awesome. All right. Well, thank you very much for your time this afternoon. Remember that we are going to have the pickup of the Marble Run kit on Tuesday and Wednesday, between 3 and 6 p.m. at Alamance Community College. So just go back to the email that I sent out earlier. And if you haven't done so already, please remember to put your name in the chat box. And
that is why they have such.
Thank you. Exactly. And thank you so much, Garrett. Thank you so much to the welding department as well. If you do have any questions, you can keep on writing them, and we will make sure that we get all of your questions answered and back to you. And otherwise, thank you so much for joining us, and have a wonderful weekend. Thank you.
Okay.